Okay, so I'm just gonna add on to our notes from the other day. And so we were looking at these Unit 1 notes, and just to kind of recap and go back to where we were, we started off by determining what makes something a solution. Remember plugging that in to see if it makes the equation true. And using that idea, we made some charts so that we could graph. We did a line and a parabola, and we did a cubic function. We then talked about specifically lines and writing equations of lines. So the slope, and this was kind of a big one, that if 0 is on top, you get a horizontal line. And if 0 is on the bottom, the slope is undefined or a vertical line. We then did the point slope form and slope intercept form. So writing equations of lines in that case. So we did it from a couple points and then also from the graph. And then finally ended up with parallel lines having the same slope and perpendicular lines, their slopes being opposite reciprocals. All right, so I'm going to now go ahead and talk about functions. So you've been doing a lot of functions already in your life. You don't even know it and probably didn't refer to it as a function. But a function doesn't have to be math. A function is any kind of relation. So if I could just generally, before I get into the guided notes, think of a function as just some big dumb machine. So this is supposed to be my picture of a machine with an opening on the top and an opening on the bottom here, okay? So this is our function machine. And what we do is we drop stuff into the function. And it does its work inside of here, and then it spits stuff out, okay? Well, of course, this being math class, we typically drop numbers or variables or things like that. So usually we say our x value are things that we put into the function. Okay, that's also called the input when we are talking about functions, which is also referred to as the domain. So the domain and the input and the x are kind of synonymous when we're talking about functions. Those are all stuff that we put into the function. Okay, so the domain are things that we can put into a function. And then the function itself is often an equation. So let's say, the function might be whatever we put in, we're going to multiply it by 3 and then subtract 2. Okay, so our function, which is denoted like this, it's usually f. It can be any letter, but that's kind of the name of the function. So f of x, we would say that, is equal to 3x minus 2, just like y equals 3x minus 2, okay? So we're going to take stuff, drop it into the function. Whatever we drop in there, it's going to multiply it by 3 and then subtract 2, and then it's going to spit out an answer. Well, the stuff that it spits out is typically the y value. Okay, if you drop in an x, then you do that number times 3 minus 2, and it spits out a y value. That is the output, which is the range. Okay, so for example, in this, and the reason I say it's just a big dumb machine is because this thing doesn't know anything else to do except whatever you put in there, it multiplies it by 3 and subtracts 2. It doesn't have any other use in the world. Okay, and of course, whatever the function is, that's what happens inside the box. So if we take, if 5 is our input, it's going to do 3 times 5, which is 15, minus 2, which is 13, and it's going to spit out 13. Okay, 5 is the input, 13 is the output. All right, so that's kind of just what a function is. It's just something that does an operation to whatever you put into it, and it spits something out. The stuff you put in is the domain. The stuff it spits out is the range of the function. So getting to these guided notes here, we work in equations quite a bit in math, but a function doesn't have to be mathematical. If you had a relationship between the time of the day and the temperature at that time, that relation is a function. because for an input, your input is your time. So let's say right now is 228. That would be your input. And your output would be what's the temperature at 228. And whatever it is right now, it's cold. It's probably 62 degrees. So your input is 228. Your output is 62 degrees. In a couple minutes, our input would be 230, and our output might be 62, it might be 64, whatever that output is going to be. Okay, so we can represent those as ordered pairs. You know, again, the input is typically your X, and your output is typically your Y when you want to write those things on some sort of XY graph. So let me go down here and say which of these are functions. So there's a key element to functions, and that is that for every input, there is a unique output. That means when you input something, so back in our function box here, if I input something into this function, it always has to spit out the same thing. So like before, we input a 5 and it spit out a 13. If you input 5 again, it's still going to spit out a 13 because it's a function. Well, this particular relationship right here, this is not a function, okay? This set of data. It's not a function because of these data points right here. The first set of data points, we input 2 and we got an output of 11. And then we input 2 again and we got an output of 10. That can't happen in a function. For a function, you always have to get the same output for a given input. So every time you put in a 2, you always have to get the same number out. So that means that is not a function. This is a function. It is a function because for those points, like for this one, remember the coordinates of that are -2, 3. So for an input of -2, the output is 3. For an input of -1, the output is 0. For an input of 0, the output is -1. For an input of 1, the output is 0. And for an input of 2, the output is 3. That is a function. Okay, even though we got the same output here for those two things, that's okay as long as every time I plug in -2, I get out a 3. As long as every time I plug in a 0, I get out a -1. You always have to get the same output for a given input. Well, one way that we can check that is graphically, is what's called the vertical line test. Okay, here's what the vertical line test does. It says, if you can draw a vertical line anywhere on the graph and hit the graph in 2 spots, it is not a function. So for example, and I said 2, it really should be more than 1 spot. B is not a function. It is not a function because when I draw that vertical line, it hits it there and there. It hits it more than once. Whenever you draw a vertical line, it can only hit the graph in 1 spot. So B is a function because everywhere I draw vertical lines.
You mean it's not?
No, A is a function. Did I say B?
Yeah.
I'm sorry, my mistake. Thank you for, A is a function. B is not a function. Okay, A is a function because wherever you draw a vertical line, it's always hitting it in only 1 spot. Okay, therefore C is a function also. Okay, it passes the vertical line test, we say. And if you think about these examples we did up here, you know, this passes the vertical line test. When I draw a vertical line, it only hits that point in 1 spot. That passes the vertical line test. If you were to graph these points for an input of 2, we had an output of 11. And then for an input of 2, we had an output of 10. doesn't pass the vertical line test. Okay, so that's not another reason it's not a function. So it has to pass the vertical line test. All right, any questions before I move on from that? All right. So this is all about notation in this next section. The math part is not going to be so bad, but just knowing what's being asked. G is the name of the function. Like all of you guys have names. So when I say, hey, Melissa, she knows who I'm talking about. Well, functions have names too. This function's name is G. This function's name is F. And the letter in front is just the name of the function, okay? This is what the function actually does. And then this is the input or domain, the value we're going to put into the function. So when we're finding G of 2, what this means is take 2 and plug it into G. Well, here's G up here. So all you're going to do is replace all the X's with 2. So I'm going to put a 2 in there and in there. So it'll be negative 2 in parentheses squared plus 4 times 2 plus 1. Now remember to use your parentheses when you're plugging them in. So because in this case we do 2 squared, which is 4, and then that's minus 4 plus 8 plus 1, and so we get 5. So we would say G of 2 is equal to 5. All right, G of T is a little bit different. It means we're just going to take T and plug it in for the X's. So I'm going to do negative, use my parentheses, T squared plus 4 times T plus 1. That is G of T. So G of T equals that. That's our answer. To find G of X plus 2, that means I'm going to take X plus 2 and plug it in for the X's. So this might take a little algebra here because we're going to do negative X plus 2 in parentheses squared plus 4 times X plus 2 plus 1. Now we got to clean that up. So this thing I have to FOIL. So that's, I'm going to leave my negative outside, and that FOIL is going to be X squared plus 4X plus 4. And then I have to distribute my 4. So I have plus 4X plus 8, and then plus 1. So I'm just simplifying and combining my like terms. Distribute our negative sign. So I get negative X squared minus 4X minus 4. And now combine my like terms. Looks like we get negative X squared plus 5. All right, so to do the next one, real similar problem, okay? And just to kind of go through those examples again. F, because it's F, that just means we're looking at a different function. We're looking at this guy and not the one above it. So when we find F of 2, that means I'm going to take 2 and plug it in for the X. So I'm going to do 10 minus 3 times 2 squared. So do 2 squared, which is 4 times 3 is 12, of course. And so F of 2 comes out to be negative 2. All right, any questions yet? Okay, I'm gonna keep going then. So f of -4, I'm gonna plug -4 in for the x's. So I have 10 minus 3 times -4 quantity squared. So don't forget -4 times -4 is positive 16. And 16 times 3 is 48. So f of -4 is equal to -38. And now f of x minus 1 means I'm going to do 10 minus 3 times, in parentheses, x minus 1 quantity squared. Now I got to do a little algebra magic to clean that guy up. So I have to FOIL this out first. When you FOIL that out, that's going to be x squared minus 2x plus 1. And I'm going to distribute the -3. I have 10 minus 3x squared plus 6x minus 3. And then combine and write in descending order. So we have -3x squared plus 6x plus 7. So the stuff in parentheses, that's our input, which is our domain. And then the answer that it gives us, that's the output, which is the range. Now to do a piecewise function, this crazy thing is all one function, but it looks weird. That function means, you know, this function box, when you have that box, it means any value that you plug in that's less than 0, the box is going to do this stuff to it. But any value that you plug in that's greater than or equal to 0, the box is going to do that stuff to it. So it does kind of two different things depending on what you put in there. So this is like your domain restrictions with a, you know, what it's going to do relative to the domain. So for example, if x is -1, well, -1, of course, is less than 0. So that means I'm going to plug it in and it's going to do this. So I'm going to be plugging it into the top, as opposed to 0, which is going to plug into the bottom, because anything that's greater than or equal to 0, we plug into the bottom. So in this case, we're plugging some of them into the top, some of them into the bottom, depending on this part. So when I plug -1 in here for x, I get -1 quantity squared plus 1. Remember, -1 quantity squared is +1, so 1 plus 1 is 2. Now, if x equals 0, that means I have to plug it into the bottom. So that's just going to be 0 minus 1, which is -1. And if x equals 1, well, 1 is also, you know, greater than 0. So I'm going to plug that into the bottom. So we get 1 minus 1, which is 0. So in a piecewise, we just have to be careful of whether we're plugging it into the, you know, what part of the function we're plugging it into. All right, before I move on from those, are there any questions? All right, well, now I'm going to throw a good one at you. We're going to give you your first lesson in calculus, everybody. So pay attention. This is going to take a little brain power here, okay? we're first going to go through the mechanics of what's happening here. This thing, believe it or not, right here is a big basis of much of what we do in calculus. It's called the difference quotient. You don't need to know that right now, but it does have a name. And it's actually just a fancy way of finding a slope between 2 points. I'll get to that later. What I want to do is use what we just learned about function notation and plugging things into a function to find this big ugly thing, f of x plus h minus f of x all over h. All right, so here's how we're going to do it. We're going to find f of x plus h first. That means I'm going to take x plus h and plug it in for the x's, okay? So f of x plus h is going to be x plus h quantity squared minus 4 times x plus h plus 7. Okay, so that is f of x plus h. I just plugged x plus h in for these x's here. Now I want to subtract f of x. Well, f of x means plug x in for x. It just looks exactly like the function does. So it's going to be minus, in parentheses, x squared minus 4x plus 7. So the orange part is f of x plus h, and I'm going to subtract the purple part, which is f of x. So that's all f of x plus h minus f of x. And then remember that whole thing is over h. All right, so I just used what we were just talking about plugging in values into the function. But now we need to do a little algebra to clean this whole thing up. I have to FOIL f of x plus h. When you do that, you get x squared plus 2xh plus h squared. Then I have to distribute the negative 4. So it's going to be minus 4x minus 4h. And then plus 7. Okay. In fact, maybe I'll go back before I'm going to rewrite those. So might as well write them in orange as long as I'm color coding here. So that was x squared plus 2xh plus h squared minus 4x minus 4h plus 7. Now I have to distribute the negative sign to that purple stuff. So that's going to be minus x squared plus 4x minus 7. And then that's all over h. So this is a doozy. We got lots of stuff going on here. But in my next step, I'm going to combine. And luckily, things cancel out. Like our x squareds, when I add those, I have positive x squared, negative x squared. I have minus 4x and plus 4x, gone. I have 7 and minus 7, gone. So we're left with 2xh plus h squared minus 4h. I think I said x here, but I meant to write h. In that line, guys, I think I said h, but I wrote x. So that is for h. And that's all over h. And we have one more step. Because I have h's all on top and the bottom. I can cancel an h from here, 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 and here. And we're left with 2x plus h minus 4. That is our answer. That is our difference quotient. All right, before I try and explain what that is, does anybody have any questions? Because it's going to take a real brain power on trying to explain it. All right, well then, stick with me here, guys, okay? Because I'm going to try and explain exactly what that is. And I don't expect everybody to get it, but eventually you will, because we'll explain it over and over and over again many times. This thing is it's a parabola, x squared minus 4x plus 7, okay? So it's a parabola, and it opens upward, and I don't have any idea where it is on the graph. But what this thing allows us to do is it allows it, the parabola is, you know, if you were like riding your skateboard on the parabola, the parabola is going down and decreasing here, and then you slow down, and then you hit 0, and then you're going uphill, and it's increasing, and then it's increasing real quickly there. So what this does is it allows us to pick any 2 points on the graph. So I could pick one, let's say right here, and I can pick one right here, and I can find the slope between those 2 points. And I know you might be thinking, well, why would you ever want to do that? What the slope is, remember, slope is average rate of change. So if I found the slope of that line, it actually is, you know, this graph is decreasing a little bit here, and then it starts increasing, and then it increases more quickly. But if you took all of those little changes and you averaged them all out, the average would be the slope of that line, which we could find using the difference quotient. So for right now, I really want to get the algebra down here so that once we start to analyze that, we have a little bit better feel for that. All right, any questions for me before we go on to class kick? Okay. All right, so on the class kick, here is number, oh, that was 86. I think we want to take a look at 85 first. So number 85, here's the work, but I want to point out a couple things that are really common mistakes. This was the function, okay? And we are trying to find this. Now, some of you had questions that said h not equal to 0. All right, the good news is we don't have to worry about that. So you can kind of place that out of your mind. The reason that's there, that's just a disclaimer, because if h is equal to 0, this is undefined and you can't do the problem at all. So basically they're saying, just imagine that we can do the problem. Okay, that's all what that h is not equal to 0 means. So to solve this, to find f of 2 plus h, don't forget, that goes here. Don't forget to put your 2 plus h in parentheses. If you don't put it in parentheses, you're gonna mess up a plus or a minus somewhere, I guarantee it. And you might forget to FOIL also. So you have to make sure you put that in parentheses. The second really common mistake is the second set of parentheses here. Because if you don't remember to put that in parentheses also, you're very likely to forget to combine those before you subtract or to distribute the negative sign. And of course, you're then going to get it wrong. Okay, but if we set it all up here, that's using the difference quotient, then it's just a matter of algebra. It's foiling, it's distributing, it's combining like terms, all things that you're good at, but we have to do them all at once. So then in our next step, we get 4 plus 4h plus h squared. And then notice I distributed that, so minus 2 minus h plus 1, and then minus the 3, because the 3 all came from that stuff there. Okay, so those parentheses really help. Now to get from this step to this step, we are just combining our like terms, and when you do that, a lot of times ugly stuff cancels out, which is nice. And once we combine the like terms, now from here we can cancel an h there, and there, leaving us with h plus 3, which is the solution. That is the difference quotient.